Hi everyone, in this video we will be looking at examples of solving quadratic equations using the factorisation method. The examples I'll be using are available in the link in the description in case you want to give them a go yourself, and there is also some timings for different parts of the video there, so you're able to skip to a certain question. Now the idea of this video is that you're able to see how to approach different types of quadratics, as well as learn some tips and tricks that might help you along the way. And there are a lot of examples in this video, meaning there is a lot of repetition. This should help you remember the method as long as you try to give the questions a go yourself. As I go through the questions, I will assume that you have some prior knowledge about quadratics, but if not, then first watch the recommended video in the description so you can nail the theory before you watch this video. So let's start the examples. Now, as I go through these, I'll start by talking through exactly what I'm doing in detail, but as we go on, I'll speed up as you'll have an understanding of the basics. We're going to start with looking at examples that just contain positive numbers. And the first question asks us to solve the following quadratic equations, and then we have a list of different quadratic equations underneath. Now the first equation is x squared plus 4x plus 3 is equal to 0, and the question is obviously asking us to solve this. Now whenever I see the word solve, I always think this as I'm being asked to give values that make the thing we're talking about, which is quadratic equations in this case, true. Meaning what makes this equation valid and actually work. So I know that the goal I'm heading towards is to have an answer that's something like x is equal to some number, or y is equal to some number, or whatever the variable we're using is equal to some number. And that's where if we were to substitute the number in, it would make the equation, or whatever it is we're talking about, true. So we know that what we're going to put in our answer line is something like x equals some value, and we might have two different values for x, or one value for x, or sometimes there's no values for x. We're going to use factorisation to answer this question, but the way I'm doing it might not be something you're used to. So if you are used to your own method and you can do that successfully, then go ahead and use that. But the way I'm going to do is I'm going to create a little table on the left hand side just to help me. And at the top of the table in each column we're going to have an addition sign on the left and then a multiplication sign on the right. And essentially what the goal is on the left hand column we want two values that add together to equal the value of b. So if you remember, a quadratic equation is in the form of ax squared plus bx plus c is equal to 0. So in this case we have a is equal to 1, b is equal to 4 and c is equal to 3. So our b value is equal to 4, so I'll just put that right there because we'll need that later. And then our a and c values are equal to 1 and 3. So in the second column, I want to put a times c is equal to 1 times 3, which is equal to 3. And this is the bit that might be a little bit confusing, and you might not have seen this method before, but just bear with me because when we get on to further examples, you'll know why I'm doing it this way. Okay, so now what we want is we want two values that add together to equal 4 in our first column, but then them same two values we can times together to equal 3 in our second column. So let me show you what I mean. So we want two values that add together to equal 4, so let's just start with 1. If we do 1 plus 3, that is equal to 4. And then if we do them same two values multiplied together, we need to get 3. So if we do 1 times 3, that's equal to 3. Cool, so this one works. The numbers we want is 1 and 3. Which means now what we can do is set up our double brackets. So you would have seen these before. Like this. And then the two values we want inside our double brackets are 1 and 3. Since we're just dealing with positive numbers at the moment, it's just positive 1 and positive 3. So let's see what we've actually achieved here. So if we expand these brackets, what should happen is we should get to the original equation that we had before. So if we do x times x, we have x squared. And then if we do x times positive 3, we have positive 3x. Then we'll do positive 1 times x, which is just positive x. And then positive 1 times positive 3 is just positive 3. And that all equals 0. So we'll just simplify what we've got here. So we've got x squared plus 4x plus 3 is equal to 0. And that's what we started with. So we know that our factorisation is correct. And what we've just done is we've put our equation into a form where we now could easily recognise what two values of x would make this equation equal 0. So let me explain what I mean. So in our first bracket we have x plus 1, and then this is multiplied by the second bracket, which is x plus 3. So if either one of these brackets were equal to 0, this would make the whole equation equal to 0, because obviously anything times 0 is 0. So we could have 0 times x plus 3, and we could also have x plus 1 times by 0. So now what we need to do is figure out, well, what would make these brackets equal 0? So there's a couple of ways we can do this. We can either do it in terms of algebra and say, right, we have x plus 1 equals 0. What would x be? So obviously x would be minus 1, because minus 1 plus 1 is equal to 0. Or we could literally just stare at the bracket, because we have x plus 1, and then just straight away realise that minus 1 plus 1 equals 0. And what we're actually doing is we're actually just changing the sign of the number that's already inside the bracket. So if we have x plus 1, if you just change the sign of plus 1 to minus 1, that is our value of x. So that if we were to substitute x equals minus 1 into the equation, you would have minus 1 plus 1, which gives us that 0 in that bracket we need. So the same thing applies to the other bracket, x plus 3. We can either do that in terms of algebra and say x plus 3 equals 0, what's x? Or you can literally just stare at the bracket and say, right, something plus 3 is equal to 0, which again we can just flip the sign from positive 3 to minus 3, because minus 3 plus 3 is equal to 0. So hopefully that bit makes sense to you, because that's the most important bit of the question, because what we actually have is two values which make this equation true. We have x equals minus 1, or we have x equals minus 3. So let's just give that a little try a second. So let's say x was equal to minus 1, what would we have? We'd have minus 1 plus 1, which is 0, and we would have 0 times minus 1 plus 3. So let's deal with a minus 1 plus 3 first. So obviously minus 1 plus 3 is 2. So now we have 0 times 2, and anything times by 0 is just 0. So that value of x works. And then the other value of x, so x is equal to minus 3, let's try that one. We have minus 3 plus 1, which is minus 2. Minus 2 times minus 3 plus 3. Now minus 3 plus 3 is 0, so we have minus 2 times 0, and anything times by 0 is 0. So hopefully you realise that these two values of x both make this equation true. And in fact, they are the only two values of x which would make the equation true. You could try any other value and the equation would not equal 0. So now as our final answer, we want to put x is equal to minus 1 or x is equal to minus 3. And obviously we're using x to represent a value, so that value can't be two numbers at the same time. So that's why we need to put or. So x can either be minus 1, which makes the equation true, or x can be equal to minus 3, which would also make the equation true. But x can't represent two values at the same time. So I don't expect you to grasp fully what we just did there, especially in terms of the table, but we'll just keep answering plenty of examples and then you'll hopefully get used to the method. So the second equation, we have x squared plus 5x plus 6 is equal to 0, and we need to do the same thing, we need to solve. So we know that our final answers are going to be x equals something. So we'll set up our table again, so let's do that over here. And in the first column, we want two values that add together to make 5, because b equals 5. And then we want the same two values to times together to make a times c, which equals 1 times 6, which is equal to 6. Okay, so we'll start with 1 again. If we do 1 plus 4, that's equal to 5. And if we do 1 times 4, that's equal to 4. So this one doesn't work. Next, if we do 2 plus 3 is equal to 5, and then if we do 2 times 3, that equals 6. So this one does work because we have 2 and 3, which when added together equals 5, but when we times them together equals 6. So these are the two numbers we need to use. So now we can set up our double brackets, and we will have x plus 2 and x plus 3 is equal to 0. And now let's just double check what we've done is correct. If we have x times x, we have x squared. X times positive 3 gives us positive 3x. Positive 2 times x is positive 2x. And then positive 2 times positive 3 is positive 6. Now that all equals 0. And let's just simplify this. So we have x squared plus 5x plus 6 is equal to 0, which is what we started with. So that means our factorisation is correct. Now we just need to figure out the values of x which make the equation equal 0. And obviously the reason why we factorise is to make that easier to see. So yeah, then we can think of this two ways. We can say x plus 2 equals 0, so what's x? Or we can just stare at the bracket and just say, you know, we've got x plus 2 and that needs to equal 0, so obviously x equals minus 2, which is just flipping the sign of the number we already have inside the bracket. So we have a plus 2 and a plus 3, so our answer is going to be minus 2 and minus 3. So x equals minus 2 or x equals minus 3. And remember, x can't represent both numbers, so we have to write or in between the two answers. So that we're letting everyone know that x can only equal that number one at a time. So next we'll move on to the next example. So we have x squared plus 21x plus 20. So same again, we'll set up our little table. We want two things that add together to make 21, because b is equal to 21. And then we want two things that times together to make 20, because a times c is 1 times 20, which is equal to 20. So we'll start with 1 again. So we have 1 plus 20 is equal to 21. And then we have 1 times 20 is equal to 20. Cool, so this one straight away is the one we want, because we have two values that add together to make 21, and we have the same two values that times together to make 20. So we'll set up our double brackets, and we have x plus 1, and we have x plus 20. And then obviously we need to check this just to make sure we haven't made any mistakes. So if we do x times x, we have x squared. We do x times positive 20, we have positive 20x. Then we have positive 1 times x is just positive x. And then we have positive 1 times 20 is just 20. That all equals 0, and then we'll simplify this to get x squared plus 21x plus 20 is equal to 0. And this is what we started with, so we know our factorisation is correct. So now we need to look at our factorised equation and say what two values of x make this equal to 0. We have x plus 1 and we have x plus 20. So if we change the signs of the numbers inside the brackets, we have minus 1 or minus 20. So we simply put x equals minus 1 or x equals minus 20. And again, we can check that. If we substitute x equals minus 1 in, we get minus 1 plus 1, which is 0, and anything times 0 is 0. And same again, if we substitute x equals minus 20 in, we would get minus 20 plus 20, which is 0, and same again, anything times 0 is 0. So far that's nice and easy. So now we're going to move on to some more examples. So we have x squared plus 8x plus 12 is equal to 0. So we'll set up our little table. We have b is equal to 8. And then we have a times c is equal to 1 times 12, which is equal to 12. So two things that add together to make 8. So we'll start with 1. So 1 plus 7 is equal to 8. 1 times 7 is equal to 7. So that one doesn't work. Now we want 2 plus 6 is equal to 8. And 2 times 6 is equal to 12. Cool, bingo, we've got it. So now we'll set up our double brackets. We have x plus 2 and x plus 6, and that's all equal to 0. And then let's check. X times x is x squared. X times positive 6 is positive 6x. Positive 2 times x is positive 2x, and positive 2 times positive 6 is positive 12. That's all equal to 0. Let's simplify that. X squared plus 8x plus 12 is equal to 0. This is the same as what we began with, so we know our factorisation is correct. And then nice and easy, we have x plus 2, so x is equal to minus 2. And in the other bracket, we have x plus 6, so x is equal to minus 6. Well, should I say, or x is equal to minus 6. So the next one is we have y squared plus 8y plus 16 equals 0. You do typically use x, but sometimes it can be a different letter, because at the end of the day they're just representing a value. So we do nothing different apart from we just need to remember that everything needs to be a y instead of an x. So if you end up putting your answer as x equals something, then really there's no x in your equation. So you sort of be talking nonsense, so just be careful with that. So we'll set up our column again. B is equal to 8. And A times C is equal to 1 times 16, which is equal to 16. We'll start with 1 again, so 1 plus 7 equals 8. And 1 times 7 is equal to 7, so that's no good. We've got 2 plus 6 is equal to 8. 2 times 6 is equal to 12, so that's also no good. And 3 plus 5 is equal to 8, and 3 times 5 is equal to 15, which is also no good, so let's try again. If we do 4 plus 4, that's equal to 8, and 4 times 4 is equal to 16. Bingo, we've got it. So now we'll set up our double brackets. So remember we have y, so we have y plus 4 times y plus 4. Which is equal to 0. So if we expand this, just make sure that we haven't done anything incorrectly. We've got y squared plus 4y plus 4y plus 16 is equal to 0. And we tidy that up, we've got y squared plus 8y plus 16 is equal to 0. And this is what we started with. Now it's just worth mentioning that instead of putting y plus 4 times y plus 4, this would usually be written as y plus 4 all squared is equal to 0. And the reason why is because we haven't got two solutions that are going to make this equal 0. Actually, both of those solutions for y are just going to be minus 4. So if we write it as y plus 4 all squared, this just gives us one y inside our bracket, which obviously corresponds with just having that one solution later on. So the answer to this one is y is equal to minus 4, because if we have minus 4 plus 4 is 0, and obviously 0 squared is 0. So we'll move on to the next question. We have y squared plus 11y plus 30 equals 0. So we need to remember it's y again. So we'll set up our little table again. So we're going to have b is equal to 11, and a times c is equal to 1 times 30, which is just 30. And start at 1 again. If we have 1 plus 10 is equal to 11, but 1 times 10 is equal to 10, and we don't need that. 2 plus 9 is equal to 11, and 2 times 9 is equal to 18, so that's no good. 3 plus 8 is equal to 11, and 3 times 8 is equal to 24, so that's no good. And 4 plus 7 is equal to 11, and 4 times 7 is equal to 28, so that's no good. And then 5 plus 6 is equal to 11, so 5 times 6 is equal to 30, finally, so that's the one we want. Now we can set up our double brackets. So remember we're using y, so we need y plus 5, all times by y plus 6 is equal to 0. And let's just check this, make sure we haven't made any mistakes. So we've got y squared plus 5y plus 6y plus 30 is equal to 0. And then simplify this, we've got y squared plus 11y plus 30 is equal to 0, which is what we started with, so we know our factorisation is correct. And then we need the two values of y which make the equation true. So if we flip the signs of the numbers that are inside the bracket, we've got plus 5, which means y equals minus 5, or we have plus 6, which means y equals minus 6. So that's the end of the positive number examples. We're going to move on to the negative number examples now. And this is where it might get a little bit more difficult because there is a bit of thinking to do, but I'll show you some tips and tricks just to get around any difficulty. So the first question we have, it still says solve the following quadratic equations, so we're just doing what we did before. The first question is x squared minus 3x minus 18 is equal to 0. So we'll start off with our table again. And we've got b is equal to minus 3 this time. And then a times c is equal to 1 times minus 18, which is just minus 18. So the same principles apply, apart from sometimes when we're dealing with minuses, it can take us a little while to eventually get to the two values which meet both criterias. So let's just stop and have a little think for a second. So we need to end up where the b value is a minus, and then also the c value is also a minus. And obviously if we times two minus numbers together, we're going to get a positive. So one number always needs to be positive. But also if we add two numbers together and the number we choose that's the minus is too large, we might end up with a really small number, which is obviously important because you will eventually get to the numbers you need, but it could take you a while doing so. So just by having a quick think beforehand, we'll be able to reduce the amount of work we need to do basically. So for example here, I'd be tempted to start with minus 1 usually, but because we've got b is equal to a minus number and a times c is equal to a minus number, I'm going to use the bigger number I use as the minus. So I'll show you what I mean. So I'm going to have 1 plus minus 4 is equal to minus 3. And then we're going to do 1 times minus 4 is equal to minus 4. So that's no good. Next we have 2 plus minus 5 is equal to minus 3. And then we've got 2 times minus 5 is equal to minus 10. So that's no good. Now we've got 3 plus minus 6 is equal to minus 3. And then 3 times minus 6 is equal to minus 18. Cool, so that's the one we need. So that means we can set up our brackets and have x plus 3 and x minus 6 equals 0. And then if we were just to check that by expanding, we'll have x times x, which is x squared. X times minus 6 is minus 6x. Positive 3 times x is positive 3x. And then positive 3 times negative 6 is negative 18. That's all equal to 0. And then if we just to simplify what we have x squared minus 3x minus 18 is equal to 0, which is what we started with, so we know our factorisation is correct. And then this means we can just use the same rule we were using before, where we need something plus 3 is equal to 0, and then something minus 6 is equal to 0. So we do the same thing just by flipping the sign of the number that's in the bracket. So for x plus 3, we're going to have x is equal to minus 3. And then for x minus 6, we're going to have x is equal to positive 6. So that means we have x is equal to minus 3 or x is equal to positive 6. So there's not much difference there. It's just that you have to do a bit of thinking about if you need any of your values to be minus, and if they were both to be minus, what would happen, or if one of them was minus, what would happen. And then other than that, the method is exactly the same. So we'll do the next example. We've got x squared minus 49 is equal to 0. So this is still a quadratic, it's just the fact that there's no bx term. So we'll just do the same thing, we'll set up our little table over here. Our b actually equals 0, and then a times c is equal to 1 times minus 49, which just equals minus 49. And then we just need to stop and think just for a moment. So if we have b equals 0, then we're obviously going to have some number minus the same number. Or we can have minus a number plus the same number, as they'll equal 0. So we need two numbers that are useful when we times them together to make minus 49. But when we add those two numbers together, they actually cancel each other out. So those two numbers have to be the same number. It's just that one of those numbers is going to be a minus number. And hopefully we can all recognise that 49 is a squared number because 7 times 7 is 49. So instead of starting from 1 and building up, we can immediately recognise that the numbers that we want are going to include 7. So for the sake of completion, let's just write this down. So if we have minus 7 plus 7, that's going to equal 0. And then if we have minus 7 times by 7, this will give us minus 49. So minus 7 and 7 are the numbers we want. There's actually a special name for this type of problem. It's called the difference of two squares. And what it means is, when you put it into a factorised version like this, so we've got x minus 7 times x plus 7 equals 0. Then if we were to expand that and have x squared minus 7x plus 7x minus 49 is equal to 0, the x terms cancel out because we've got minus 7x plus 7x, which is 0. So we're just left with x squared minus 49 is equal to 0. So this works whenever we've got x squared minus a squared number. So where there's no bx terms. So we could have x squared minus 81 or x squared minus 100. And it means that if you just square root the square number, they're going to be the two values that we want. So in this case, we have x is equal to positive 7 or x is equal to negative 7, and another way of writing that is saying that x is equal to plus or minus 7, and then that covers both values. So the next example is we have x squared minus 2x minus 8. So we'll just create our table again. We have b is equal to minus 2, and we have a times c is equal to 1 times minus 8, which is equal to minus 8. So we can just use our normal method now. So we need two things that add together to make minus 2, but times together to make minus 8. So we'll just do what we did before, and we'll have 1 plus minus 3 is equal to minus 2. And then we'll have 1 times minus 3 equals minus 3, so that one's no good. Then we'll have 2 plus minus 4, which equals minus 2, which gives 2 times minus 4, which is equals minus 8. Which is the one we want. So we've got 2 plus minus 4 equals minus 2, and we've got 2 times minus 4, which equals minus 8. So we can set up our brackets. We've got x plus 2 times by x minus 4 is equal to 0. And then if we were to expand that just to check it, we have x squared minus 4x plus 2x minus 8 equals 0. And simplify that with the x squared minus 2x minus 8 equals 0, which is what we started with. So we know our factorisation is correct. Now this means that x equals minus 2 or x equals positive 4. So we'll move on to the next question. So we've got y squared plus 10y minus 24 equals 0. So we'll set up the table again. B is equal to 10. And then a times c is equal to 1 times minus 24, which equals minus 24. And this is one of those problems where we have to do a little bit of thinking again, because we want two values that add together that give positive 10, but we want two values that times together to give minus 24. So we know that there's a minus included, but when we add the values together, we need to make sure that the positive value is much greater than the negative value, so that we get positive 10. But then when we times the two values together, we also need to make sure that one of them is negative. So let's give it a shot. So let's try. Minus 1 plus 11 equals 10, and then minus 1 times 11 is equal to minus 11, so that one's no good. If we have minus 2 plus 12 is equal to 10, which gives minus 2 times 12 is equal to minus 24. Cool, so that's the one we need. So we have minus 2 and 12, so we set up our brackets here. we've got y, not x, so we need to make sure it's y minus 2 times y plus 12 is equal to 0. And then we'll just check this just by expanding the bracket. So we have y squared minus 2y plus 12y minus 24 is equal to 0. And then we'll simplify this so we get y squared minus 10y, positive 10y minus 24 is equal to 0, which is what we started with. So we know our factorisation is correct. Next, if we have y minus 2 times y plus 12, then we know that y is equal to 2, which would make the equation 0, or y is equal to minus 12, which would also make the equation equal to 0. So we'll move on to the next example. We've got t squared minus 13t plus 30 is equal to 0. So b is equal to minus 13. And a times c is equal to 1 times 30, which is equal to 30. This time it's slightly different because the minus and the plus sign are in the opposite places. So we have b as a minus number and a times c as a positive number. So we just have to do a little bit of thinking again. So we need at least one minus number to be able to create our minus 13 for our b value. But then if we're timesing them two numbers together, the only way to make a minus turn into a positive is if we were to times by another minus. So when we times the two values together, both values need to be minus in order to achieve a positive number. Which is okay because you can have two minus numbers added together to get minus 13. We just have to find those two numbers. So let's start with minus 1 again. So if we have minus 1 plus minus 12, then that would give us minus 13. And if we have minus 1 times minus 12, that would give us positive 12. So that's worked. We've got our minus number for our b value, and we've got a positive number for our a times c value. We just haven't got the numbers we want. So next, let's try minus 2 plus minus 11, which gives us minus 13. And then if we do minus 2 times minus 11, we get positive 22, which isn't the number we want. So let's try again. If we have minus 3 plus minus 10 equals minus 13. And if we do minus 3 times minus 10, we get positive 30, which is what we want. So we know our values are t minus 3, because we're using t, not x, times by t minus 10, which is all equal to 0. We'll just expand that so we know we've factorised correctly. So if we have t squared minus 3t minus 10t plus 30 is equal to 0, we'll simplify that so we get t squared minus 13t plus 30 is equal to 0. And that's what we started with, so we know our factorisation is correct. So next we just need to state that t is equal to positive 3 or t is equal to positive 10, because 3 would make the first bracket equal 0 and 10 would make the second bracket equal 0. So we'll move on to the next example. We've got m squared plus 4m minus 12 is equal to 0. So I'll set up my table. We have b is equal to positive 4, and we have a times c is equal to 1 times minus 12, which equals minus 12. So we've dealt with this type of problem before, where our b value is positive and our a times c value is negative. So we just need to make sure we have at least one negative value to make our minus 12. And if we have a negative value, then we need to make sure we have quite a large positive value to achieve our positive 4. So if we try minus 1 plus 5, that will give us our positive 4. And then if we do minus 1 times 5, we will get minus 5, which is not what we want. So we'll try minus 2 plus 6, which is equal to 4. And then we'll have minus 2 times 6, which is equal to minus 12, which is what we want. So we have m minus 2 times by m plus 6 is equal to 0. And then we'll expand the brackets just to make sure we've done the factorisation correctly. So we have m squared minus 2m plus 6m minus 12 is equal to 0. And that gives us m squared plus 4m minus 12 is equal to 0. So we know we've done our factorisation correctly. So this means that m is equal to 2 And because we have -2 and +6 in the brackets, this means that m is equal to 2 or m is equal to -6. So that's the end of the negative examples. Next, we want to move on to examples where a is greater than 1. This is where you'll see why we do a times c in the second column, because so far a has been 1, so it might seem a bit pointless because it always ends up just being the same value as our c value. But yeah, now you should be able to see why we're doing a times c. It's because it makes our lives a bit easier later on, so let me show you why.